Hey, welcome back. It's me, Mr. Treewin. Today we're going to be going over part 2 of equation of a circle. So today we're going to be focusing on when we don't have quite all the information we need to write the equation, and then what we're going to do is figure out how to write that information or how to gather that information so we can write a circle or equation of a circle. So again, I wrote a formula from yesterday that we're going to be using. This is our equation of a circle. And I look at my first example just to jump right in and get started. I look at it and it says write the equation of a circle from the given info, and it says center 2, 1 and the point 6,4 is on the circle. All right, so I'm going to draw a little mini picture off to the side because I want to try to elaborate what does that mean if a point's on a circle. So I'm just going to randomly, and I mean randomly, just draw a little circle here. And I know right now by taking in the information, I know that I have the center and I have a point that's on the circle. Let's just put it right here. It doesn't really matter. It's just arbitrary. It's only for the point of just understanding why did they tell me that? What is it about giving me the center and another point that I'm going to be needing to do this problem? And it turns out what I'm needing is I need this radius. I already have the first part. I have the center. And if I use the formula of a circle or equation of a circle, I can write that down as x minus 2 squared plus y minus 1 squared, and I need my radius. Well, if I know that this is my center and this is on the circle, if I connect those two dots and find the distance between them, I now know the radius. So by doing this, or my way of doing this, is I'm going to use Pythagorean theorem. I can't stand using the distance formula. It's too confusing. I like Pythagorean theorem. I just got to count this way, and I've got the number I'm looking for. So if I take the 2 points that I've been given, the center being 2, 1 and 6, 4, if I were to use those, I know that for distance, when it comes to going this way, from 2 to 6 is 4 spaces. And from 1 to 4 is 3 spaces. And I know that this is my a squared, my b squared, and this is c squared according to Pythagoras. All right, well, 4 squared is 16, 3 squared is 9, and I've got c squared is equal to 25. That's awesome, but that's not the radius. That's the radius squared, or that's actually the hypotenuse squared of the right triangle that I just made. So when I take the square root of that, I get c equals 5. Now, the hypotenuse of the triangle and the radius, well, they're one and the same. So when I say that I know that the c is equal to 5, I now know that the radius equals 5. Now that I know the radius, I got to go back up to the top and I got to plug that information in. So when I come up here and I put my radius in here, I get 5 squared, which ends up being 25. Now I know that can be confusing sometimes, so I'll make sure you understood that, like I said before, the equation of a circle and Pythagorean theorem are very closely related. There's a lot of mathematical ties between the two. And one of them is when you do that a squared, b squared, you end up getting your radius squared. And that's where I end up with that. So the official answer that you will find is going to look like this. And that's the end of the problem. Just keep in mind though, your radius is not 25, your radius is 5. That bothers me when people don't know that. All right, number 2. I've got this problem here and it says, is the point -7, 4 on the circle with the given equation? Okay, so I'm asking you that if you were to plot this out and draw me a picture of that circle given this situation, would this point end up being on it? Well, I can grab some graph paper and I could grab a compass and map it all out, or I could get on Desmos and map it out. Or I can do it the algebraic way, which is simply take these two values and substitute them into the math problem. Put these numbers in the spot marked X and Y. And then see what you get. If you plug those numbers in, see what you end up getting. So -7 plus 5 is 2 squared plus 5 squared equals 36. Well, 2 squared is 4, 5 squared is 25, and I'm pretty sure that 29 is not the same as 36. These are not equal. If they were equal, I would say, hey, this point is definitely on the circle. But when I come up with numbers and I find out that the point, when I plug the point in, the point gives me a value that's less than my radius, I'm going to say, nope, this is not on the circle. And then if I have to explain, I'll say, because 29 is less than 36, it's in the circle. And that would go just the same if I ended up with a value that was greater than 36 in this case. If I had a value, say 50. Well, if I come up with 50 equals 36, that number is bigger than 36, which tells me that that number is bigger than the radius, so it's outside the circle. So on this question, you want to look for 3 situations. Are you equal, are you less than, or are you greater than? And that'll tell you. If you're less than, you're in the circle. Equal to, you're on the circle. And greater, you're outside the circle. All right, our last and final example. I'm trying to make this a short video as I've taught all this in the classroom today, and I just want to recap it and put it on the internet, make sure we have it for other people to use afterwards and my class. Last problem. I have the diameter of a circle has endpoints -4, 8, and -2, -6. Write the equation of the circle. Well, I got a problem here. I've got 2 sets of numbers, and they are not what I need. I need to know 2 things, the center and the radius, and I don't have either. I do, however, know that they are on a diameter. And so since a picture's worth 1,000 words, as they say, I'm going to draw a quick circle, and I'm going to say, well, wait a minute. A diameter is a segment that goes across a circle through its center. Okay, well, if I know the number at this end, and I know the number at this end, I don't know the number in the middle, but I know I can figure it out really quickly. So like I said, I know these 2 ends are here. I just need to know what's in the middle. Well, if I use something called the midpoint, I can figure that out. What I do is -4 plus -2, I add them together, and I divide them in half. So when you add the 2 numbers together and you divide them in half, you find the middle, or the midpoint. So in this case, -4 and -2 make -6. Divide that in half and I get -3. 8 and -6 gives me 2. Divided by 2, I end up with 1. This is the center of the circle. Now I know the center of the circle. So being as though I know that information now, I can go ahead and I can write the equation of the circle. I always write the first half of it, and then I might have to do a little work to get the other half. So let me just start by writing the first half. So I know it's going to be x plus 3 squared, because we referred this in all of the video. Whenever your center, whatever coordinates you get for the center, in parentheses, they are always the opposite sign. And I still need to know my radius. That's okay. Now that I know that this is the center, if I want to find a radius, all I got to do is find the distance from here, the center, to either the left side or the point on here or the point here. It doesn't really matter. So what I'm going to do is I'm going to take my center and I'm going to decide which one I like better. I'm going to go to either from the center to here or the center to here. Either one, it doesn't matter. Both of them are going to give you the same answer. So since -4 8's first, I'll write that one down. So finding the distance again, it's just like over there. I take the numbers and I say, well, if I go from -3 to -4, that's 1. If I go from 1 to 8, that's 7. 1 squared is 1, plus 7 squared is 49, which gives me 50. My radius is the square root of 50. Remember though, the formula says you're supposed to square the radius. What happens when I do this? If I take the radius and I square it, what happens to a square and a square root? they cancel and you just get the answer 50. Which once again kind of reiterates my ties to how distance formula or Pythagorean theorem and the equation of a circle are so closely related. All right, well, I hope that helps. That's it for this video. Have a great day. Bye.